We are doing the first chapter, Relations and Functions. Today's topic is Composition of Functions. We are doing exercise 1.5. The first 7 sums I have done in the previous 2 videos. Please go through those videos. Let us do sum number 8 now. Consider the functions fx, gx and hx as given below. Show that FOGOH is equal to FOGOH in each case. So this is a composition of 3 functions fx, gx and hx. We have done sums on composition of 2 functions. Now this sum from sum 8, we are going to do composition of 3 functions. Okay. Listen carefully. It is very simple, but you have to be careful while doing it. Okay. Now let us write down the 3 functions. Fx is equal to x minus 1, gx is equal to 3x plus 1 and hx is equal to x square. Okay. Now here we have to prove that this LHS is equal to RHS. Is it not? Okay. Let us take the LHS. In this bracket, whatever is given, we will do that first. So let us find out FOG. Write down FOG is equal to f of gx. You know how to do FOGs. We have done so many sums on it. It is composition of 2 functions only. So f of gx. Write it down. Now write down what is gx. 3x plus 1. Write it down. So now we have to find f at 3x plus 1. Okay. F at x is x minus 1. Here in place of x, if I write 3x plus 1, here also I should write 3x plus 1. So this will be equal to 3x plus 1 minus 1. See, I have written it. So f at 3x plus 1 is equal to 3x plus 1 minus 1 is equal to 3x. 1 will get cancelled. Okay. Now we found out FOG, which is 3x. Let's now find the LHS. FOGOH. Okay. So this portion you have to write like this at hx. Okay. Just like how we used to do in 2 functions. Composition of 2. First we will write f and then gx in the bracket. Like that, this you should write outside the bracket FOG and hx should be inside the bracket like this. Okay. Now write down what is hx? X square. Write it down. Okay. Now we are going to find out the value of FOG at x square. FOG at x is 3x. We just now found it. 3x. So in place of x, we are going to substitute with x square because FOG at x square we want. Okay. So here it will become 3x square. Okay. So this is the LHS, 3x square. Let's now do the RHS. Let's do this GOH first, which is inside the bracket. Okay. So write down, this is simple composition of 2 functions, g at hx. First write g and within bracket write hx. Okay. Now write down hx is equal to x square here. Okay. Now g at x square we have to find. See here, g at x is 3x plus 1. So here I am going to write x square. So here also I should write x square. So g at x square is equal to 3x square plus 1. See, I have written it. 3x square plus 1. So this is GOH value. 3x square plus 1. Write down the RHS. F of GOH. So you know how to write this. It will be, F will be outside the bracket and GOH is inside the bracket. Now we know what is GOH. 3x square plus 1. Write it inside the bracket like this. Okay, now it's very simple. F at x is x minus 1. So f at 3x square plus 1. In place of x, write down 3x square plus 1. So that will be equal to 3x square plus 1 minus 1. It will get cancelled and you get 3x square. So you can see LHS is equal to RHS. Second sum, fx is equal to x square, gx is equal to 2x, hx is equal to x plus 4. We have to find this. Okay. So let's do simple FOG, f of gx, f of 2x. F of 2x is 2x the whole square, that is equal to 4x square. Okay. Now FOGOH. So write FOG outside the bracket, HX inside the bracket like this. Write down HX, x plus 4. FOG at HX. FOG at x is 4x square. So in place of x you have to write x plus 4. So write down 4 into x plus 4 the whole square. Simplify, open the bracket, you get 4x square plus 32x plus 64. Okay, this is the LHS. Let's do the RHS. First GOH, G of HX, substitute, you will get 2x plus 8. GOH is 2x plus 8. Now F at GOH. So this 2x plus 8 will be in the bracket like this. Okay, now F in place of x, write down 2x plus 8, the whole square. Open the bracket, you get this. You can see LHS is equal to RHS. Third sum, fx is equal to x minus 4, gx is equal to x square, hx is 3x minus 4. So first FOG, f of gx, f of x square, that is x square minus 4. FOG OH is equal to FOG at hx. So write down hx, 3x minus 5. Now substitute this here in FOG. 3x minus 5 the whole square minus 4. Open the brackets, you will get this value. Now for the RHS, similarly do GOH, you will get 3x minus 5 the whole square. Then FOGOH, so value of function f at 3x minus 5 the whole square. Substitute here 3x minus 5 whole square minus 4. Open bracket, you can see LHS is equal to RHS. Question 9, let f is equal to the set of ordered pairs be a linear function from z to z, find fx. So here they have given the function as a set of ordered pairs. We have to find the linear form. Okay, this is the set form. We have to find the linear form. So the general form for linear function is fx is equal to ax plus b. So this is the general form. This is the form in which they are asking us to write this function. Okay. Now this first set ordered pair will satisfy this function. This first will be the x value. This 3 is the fx value. Always remember. This is the x, this is fx. This is another x, this is another fx, like that. So here, in this general form, let us substitute. Fx is equal to 3 and x is equal to minus 1. So here, f at minus 1 is equal to, write down x as minus 1 minus a plus b. And what is this value actually? It is f at minus 1 is 3. So this is equal to 3. Okay. Now you can see that a is equal to b minus 3. So this is the first equation. Similarly, substitute this as x and this as fx. So here x 0, this is equal to minus 1. Okay. So here b is equal to minus 1. A into 0 is 0. B is equal to minus 1. You got the value of b. Substitute here. So a is equal to minus 1 minus 3. That is equal to minus 4. So a is equal to minus 4. B is equal to minus 1. Substitute in this general formula. So fx is equal to a is minus 4 into x minus 1. So this is the general formula. Answer fx is equal to minus 4x minus 1 is equal to, if you take minus common, you will get in the bracket 4x plus 1. Even if you write like this, it is enough. In electrical circuit theory, a circuit CT is called a linear circuit if it satisfies the superposition principle given by C at AT1 plus BT2 is equal to ACT1 plus BCT2, where A, B are constants. Show that the circuit CT is equal to 3T is linear. Okay, now here this CT, this function is linear, we have to prove. Okay, to prove that we have to show that it satisfies this equation. If it satisfies this equation, then it is linear. Okay, so let us write down this equation. CT is equal to 3T. Okay, so the value of C at T1 will be naturally substitute t with t1. CT1. Why we are doing this? Because we want this in the RHS. CT1, CT2. So let's find out CT2. That is 3T2. Okay, you got this equation. Now let us take the LHS. C at AT1 plus BT2. Okay, C at T is what? 3T. If we substitute T with AT1 plus BT2, naturally here also we should write AT1 plus BT2. Okay, so in this first equation I am writing AT1 plus BT2 is equal to 3 times AT1 plus BT2. See the function C at this value. Okay, now open the bracket. Okay, now write down in this form A into 381 is A into 3T1. Why we are writing like this? Because we know the value of 3T1. Okay, so write down A into 3T1 plus B into 3T2. Okay, now this is equal to substitute CT1 plus B CT2. Okay, we have substituted, and this is nothing but the RHS. So we can see that LHS is equal to RHS, hence the function is linear. So here we come to the end of this exercise as well as the chapter. So please go through this videos once again, practice the sums. It is very simple only. You just have to follow the method.